Good afternoon, everybody. I hope you had a great week blowing a few things up and learned a few things about chemistry. But anyway, at the end of the week, let's get a few work done before we actually get into the exam. Today, I would like to spend some time to talk about, on an HSC level, what do we expect when it comes to naming for alkene, alkanol, and alkanoic acid. Mind you that this is not the comprehensive guide to actually name absolutely every single thing under the sun, but rather, we try to stick within the expectation of the HSC. I'll go a little bit further behind just for your curiosity, but hopefully this comprehensive video will give you enough information to do the exam coming up shortly. Now, to get started, the first thing I want to clarify on is to how do you name alkene. On the whiteboard up here, I've got an example out there. These are the 4 golden rules that you need to follow at any given time when you try to name these things correctly. So the first order of business is to identify the longest possible chain on your particular question. Now this one is a no-brainer because when you look at it straight, and all you have to do is 1, 2, 3, 4, 5, 6, 7, 7. So therefore, when you think about this, you will have a HAP as a prefix to identify the fact that there's 7 carbons in this particular chemical. Now, here's the tricky bit. We know that there's a double bond, so therefore it belongs to the alkene group. But how do you write it? You need to actually identify where this double bond actually occurs on the structure itself. Imagine that if you are working for a pharmaceutical company and such, if you put the bond at the wrong location, you could make the wrong drugs. You have all kinds of unexpected effects ahead of you. People may actually give you lawsuit and such. So therefore, when it comes to the position on how you put the name together, is absolutely paramount. So let's think about how do you actually identify this properly. When you try to identify the place of this double bond, obviously you identify by the associate carbon that's actually attached to. Now there are 2 ways of counting. You can either count from this way or this way. But the correct way to do it is to identify which one gives you the smallest possible locant, alright, or series of locants. In this simple example out here, imagine if I count from the right hand side, that will become 1, 2, 3, 4. 4. Whereas if I count from the left hand side, that goes 1, 2, 3. 3. So therefore, if I try to name this correctly, this should be hat dash 3 dash in. So let's look at the system that we have enforced. Number 1, between any alphabet and number, there's always a hyphen to separate them. Number 2, if you look at the alkene group, alright, the number is actually right after the prefix that identifies the length of the hydrocarbon chain. And of course, the last bit up there identifies that there is an alkene group, or I should say the double bond, that actually gives you the specific characteristic of an alkene. Now, however, if you read some of your textbooks, and also sometimes on the back of your MSDS data sheet, you will see this representation as well. Now, to clarify, both of these are acceptable in the HSC chemistry syllabus. And to make sure that you're absolutely convinced and sleep properly at night, go to the link below, alright? There's actually a file telling you from RACR, the Royal Association of Chemistry Institution, I don't know how guys cut that well. That is actually a nomenclature produced by RACI telling you exactly in HSC what I've just told you before and confirm to you that what you call the rules up there is appropriate. There. Yeah. Let's do it one more time. If you're not sure, look at the link underneath, alright, and you will see RACI official rules on how people should write up their naming for the HSC exam. Alright, let's deal with this little madness on the right hand side again. Now, compared to the previous molecule, I trust that you can see there's a little bit of structural differences. There's now 2 double bond out there, but don't be intimidated by it. Again, follow the rules. 1, 2, 3, 4, 5. That's the longest possible chain on this particular molecule. So therefore, 5 pent. Alright, I know it's incorporating the double bond in there, so therefore I know it's an in. Alright, now here's the part where people keep on getting the wrong answer. In this functional group there, I need to identify how many there are. So therefore that's 1, 2, so therefore di in. And don't forget I need to identify its location. If you are not sure, do both ways and compare the sets of numbers. If you're moving from the right to left, 1, see that's the first carbon actually, have the double bond, yeah, 2, 3, 1, 3. The first carbon that actually attached to the double bond. On the other hand, if you count from the left hand side, 1, 2, 3, 4. So between the series of number of 1, 3 versus 2, 4, I hope you can see 1, 3 is the smaller set of number, the smaller set of locants, hence 1, 3. And the next bit of warning are particular for the boys. If you have an alphabet sticking next to a number, make sure you connect that with a hyphen. Yes, connect that with a hyphen. Here, pen, hyphen, 1, 3, hyphen, di, in. That's how you name this molecule. Alright, this molecule is always a bit of a tragedy and comedy every single year. Tragedy, consider the fact that it's so awfully easy and everybody keep on, getting a little bit confused, and every few years you always get some really strange answer on exam paper. Comedy, because some of the what you call answers sometimes is so funny that you just can't stop laughing. Now, just to make sure that we get this absolutely right, let's think about the structure of this molecule first. I'm not going to tell you about the name just yet. I think that you should know about this by now, but anyway, I'm just trying to make sure that we get every single bit of detail out there. If you look at the three-dimensional model, I'll get closer to here. Alright, I hope you can see that it's a aromatic. Alright, it has a hexagonal structure with a double bond right there. Yep. Alright, so if you're trying to do this quickly, you can draw a hexagon with the extra dash up there to identify the double bond. Or, if you're trying to go through the full structural formula, you can write that. That's the chemical formula. And this guy out there, it's not benzene. It's not styrene. Alright? And it's certainly not silohexane. Alright? This thing, when you think about this, think about the rules that we have learned so far. 1, 2, 3, 4, 5, 6, it's hex, alright? But hang on, take a look at the structure. It's silo, isn't it? A cycle. Alright. Now, when you got a circle, you can pick any point to start, provided that you generate the smallest possible sets of locants. So I just picked that randomly. 1. This is the correct name. Alright, let's move on to the cousin of the previous molecule, the silohexane, alright, to this guy up here. Now, before we go any further, let's look at its molecular structure on a three-dimensional model. So if you look carefully, this guy has, in this case, 6 hydrogen, and moreover, 3 sets of double bond. Right, so let's try to name this guy properly. Number 1, I know that it's in an aromatic ring, so therefore I would say silo. 1, 2, 3, 4, 5, 6, hex. Alright, now there's 1, 2, 3. 3 sets of double bond, so therefore it will be tri in. But hang on, what did you do with this bit up there? Now think about this. In the previous section, I told you that I can pick anywhere to start, isn't it? Let's pretend I picked this guy to start. In this case, you need to follow a clockwise counting. So 1, 2, 3, 4, 5. 1, 3, 5. So this guy should be 1, 3, 5. The silohex dash 1, 3, 5 dash tri-ene. Now, in your textbook and on top of that in HSC, you know what? you can actually call it by its industrial name, benzene. However, if you're being called on to produce its IUPAC systematic name, this is the correct answer. Right, now this molecule, it's one of those molecules that you have to learn on top of those basic molecules that you have to name in the HSC syllabus. Strictly speaking, you're not required to work out the IUPAC name due to its complex structure. As a matter of fact, IUPAC systematic name actually got a special name for it. That's actually called phenolethylene. Now, a few common misconceptions about this molecule that I really need to point out. Do not call this phenolstyrene. You I see that a lot of times. You either call it a styrene or you call it a phenolbenzene, but don't try to mix the two names up together, invent something new and think that you're being innovative. No, that's a bad idea. Next. Alright fellas, I know that you're getting a little bit sick and tired of the alkene group, so let's move on to Alkanol. Now, look at this guy up there. I hope you now actually start developing the skill as well as the idea about how to name this correctly now. First up, always look at the longest possible chain. So in this case, I hope you can see that the chain up there is number 4, 1, 2, 3, 4, alright? So in this case, it's built. But it's a butanol of some sort, isn't it? It's not a normal butanol because of the very fact that there are actually 2 hydroxyl groups. Alright? So if I count from the right hand side, that becomes 1, 3. Whereas if I count from the opposite side, I'll get 2, 4. 1, 3 versus 2, 4, you always pick the smallest possible chain. So therefore, dash, 1, comma, 3, dash. Don't forget, there's 2 of these things up there, so therefore di, and then OL. Alright? This bit tells you that it's an alkanol. Alright? Common misconception, people might actually write something like this. Not correct. Some people might even write this. Not correct. Alright? Make sure OL. Alright. I've now modified the molecule a little bit to make it a little bit more challenging. Common misconception. People would say that, well, that's a functional group, that's a functional group, and guess what? That's an alkyl group, or with the ethyl group up there. That's incorrect. Because remember, rule number 1, you're supposed to find the longest possible chain. Now, be very careful about this concept of longest possible chain. Now, the pancake presentation of organic molecules sometimes can mess with your head a bit, plainly because of the very fact that it does not take into account that a single bond can actually rotate against each other. Now, what do I mean by this is, if you look at this ethane molecule right here, there's a single bond there. In nature, you know what? This can rotate. And the consequence of this rotation could mean that we might misinterpret some of these diagrams. What do I mean by this is, for example, if we actually look at the 3D structure of the same molecule right here. See the 2 hydroxyl group right there? Yeah? Now, moments ago, when we look at the diagram, some of you may think that that's just a functional group of ethyl group. But you know what? Let's rotate this. Can you see this now? This is actually just the main chain. So therefore, to name this correctly, you've got to understand that this could be here. Alright? Or alternatively, the other way of thinking it, just link the maximum possible amount of carbon that you can put together. So therefore, should you want to name this correctly, it will be 1, 2, 3, 4, 5, 6, a hex. Alright? And also, if you look at its functional group now, it's an alcohol, so therefore we're looking at OL. There's 2 of them, so therefore di. Alright, now let's think position again. I can count from this side or the opposite direction. Let's count this way. It becomes 1, 2, 3, 4, 2, 4. Or if I count this way, it will become 1, 2, 3, 4, 5, 3, 5. So therefore, when you think about this, 2, 4 versus 3, 5, 2/4 smaller. Therefore, that is the correct way to name this molecule. Now, some conscientious student, when they look at the work that they have just done, they would say, well, can I actually run in a situation like this? I've got good news for you. No, you won't be doing this in the HSC. Of course, you may actually want to learn about this. We can go through this in other tutorial just for fun. But structure that involve more than one functional group in your hydrocarbon will not be asked in the HSC. Right, let's move on to alkanoic acid now. When we talk about an alkanoic acid, I hope you can see that this bit up there is the functional group. But you see, when we do try to name them, just like trying to name an alkane or an alkene, you're trying to talk about how many carbon there is. If you're only talking about alkanoic acid, you count the total number of carbon, 1, 2, 3. In this case, I hope you can see that this is pro. And when you finish your name up there, Alkanoic acid. Alright, pro, identified, there are 3 carbons up there. However, the board of study, I want to mess with your mind by introducing this bad boy called citric acid. Alright, trust me, this is the very last one out here. The citric acid. This is a molecule that the board of study mandated in the syllabus. You have to understand and be able to, number one, articulate its IUPAC name, its structural formula, as well as know a little bit about its acidic characteristics. For today's tutorial purpose, we will stick with both just the IUPAC name as well as the structure. This is the structural formula where all the hydrogens being shown, and this is slightly condensed up here. I hope you can see we did a little bit of concession on the right hand side just to actually illustrate what's going on over there. I would say this is a slightly easier interpretation to memorize this molecule. Towards the right, yes, you've guessed it, this is the IUPAC name, and you will say, well, hang on a second, that doesn't look too much like the previous work when we actually did the alkanoic acid, because this is actually a little bit more complex than the normal alkanoic acid. Why? If you look back at the chain up there, people would say, well, hang on a second, that's like 1, 2, 3, 4, 5, should that be a pen? But it's not, because at the moment I'm not considering it as an alkanoic acid, I'm considering it as a carboxylic acid instead. So therefore, to name the darn thing properly, just try to study it instead of actually trying to reproduce it. Hydroxyl at number 2. See that? Yeah? Propane, 1, 2, 3, pro. And finally, remember, it's carboxylic acid, not like alkanoic acid, so therefore you don't count the C in there. So therefore, this whole group is the overall carboxylic acid, so therefore, 1, 2, 3. And since you got 3 lots of them, try carboxylic acid. Now, burn this inside your head. Alright, that's all I want to yabber on this afternoon. I hope you learned and heard something in this section of chemistry. And as always, I hope you turn into a professional Asian soon and kill HSC chemistry. See ya.